session. We have a few questions lined up. Some of these will look familiar, and as you guys suggested, we'll take a quick look at how to approach each one of them. To start this question here, what are they saying? The resultant moment, and then we're going to have this. This is going to be very, very interesting, and I think this should be there in a term sheet. I think we didn't work it out in that class. So I'm looking forward to that one. So here they're saying determine the resultant moment about a point A and about a point B caused by the three forces acting on the structural system shown in figure 2. Take joint A to be a fixed support. Now here, we're to take moments about point A and about point B caused by, so determine the resultant moment about point A and about point B caused by the three forces. So here that specifying the three forces acting on the structural system. Which three forces? We've got F1, F2, and F3. So we're not going for equilibrium to say that sum of forces is equals to 0. No. The question is asking us to just get the resultant moment, but they're not saying the resultant moment is equals to 0. So how do we do it? This is 2 dimensions. So getting the resultant force or the resultant moment, we'll just use clockwise to be negative, anti-clockwise to be positive. So we'll calculate the respective moments due to each force and express them as either clockwise or anti-clockwise. That's basically the approach that we take. Later on in 3D, you'll see that we'll opt to use cross product and we'll express each force in Cartesian vector form. Okay, so let's see what we need here. So let's reduce it to only what we need. We'll not look at this one, just this one. Only focus on this one on top. Okay, so what is happening? So let's start with F1. So let's say F1 causes moment M1. So F1 is strictly vertical and it's downwards. So about point A, so M1 about point A, so let's say moment about A. So what we have about A, about A, F1, we have 375 by the distance. We need the distance from point A to where the force is passing. Now here you want to be very careful. Observe that they've given you the thickness of this system. Since the thickness has been given, it's important for you to note that point A is indicated to be right at the top. It's not very clear, so let's make an assumption that point A is at the top there. So if A is at the top, F1 comes like this, or for F1, we see that there's no change. The distance will be this. So for this one, there is no change. We're going to multiply with that distance, 8 feet. I'm leaving out the units here. I only include the units at the very end when you're getting the answer. F1 causes clockwise rotation. So because it's causing clockwise, I'll give it a minus. Since I said we'll take clockwise to be negative and anti-clockwise to be positive. What will be the product here? Getting negative 3,000. So the units, the force came with the pound, the length came with the feet. Next, let's get the moment due to F2. Now F2 is acting at an angle. You have to see that it will have two components. One component of F2 will be acting sideways and it will be horizontal like that, while the other component will be acting vertically downward. The one that acts horizontal, observe that its line of action comes to pass through A. Therefore, that force will not cause a moment about A. The vertical component, however, will cause a moment about A. So we are only interested in the vertical component. So when we analyze the vertical component, we need to find it first. So again, you can choose a side, an angle again. Let's choose that angle. So we're interested in only the vertical. The vertical will be given by cosine when you make a right angle. So I am interested in cos theta, which will be adjacent over hypotenuse. So when it comes to the bigger triangle now, with the vertical being here, theta being here, notice that the y component of F2 will be given by cosine. So it will be F2 itself cos theta. F2 is 500. Cos theta, as we saw earlier, is 4/5. So 5 into 500 will be 100. 100 by 4, 400. So the vertical component is 400. Just like M1, it will also be clockwise, so minus the force, the distance. Now the distance will be all the way from here up to that point, which is 8 plus 6. What will be the product this time? Again, now we are left with only N. So we look at N3, also it will have two components. The vertical component will be coming down like this. So then the angle, we use the angle 160, so 160 cos 30. The x component will be going down like this, and to be given by sine to opposite that 30. So it's 160 sine 30. But we know it will not necessarily be at that here. The horizontal component will also be at this point here. So that will be the position of the component. So from here, if you get a moment, you have to the vertical component will also be about a so minus it was 160 plus 30 multiplying the distance. Now the distance will be from here 8 plus 6. 8 plus 6 plus 5. So this now gives us 19. But the force F3, even the x component will cause a moment about A. Why? Because when you trace its line of action, notice that it doesn't pass through A. It passes some distance below A. And that distance is specified here. the thickness of that beam. So the distance from A to B, and not to B, to where the force is passing is 0.5. So put together, we're going to have that force 160 sine 30. We can actually look at them as two separate forces creating two separate moments, so that you perhaps get your M4. Or you can combine them like we're about to do, to say that F3 will cause this. At the same time, it also causes 160 sine 30, multiplying the distance 0.5. The only difference now is that this x component of F3, notice that it will be causing anti-clockwise moments about A. So because it will be causing anti-clockwise, this one will have to be positive. If you're not comfortable with this, you can look at them as two separate forces. Sometimes to cause M4. In this approach, you'd have to get this and bring it here. In the same way, you'd still get the same answer. So what would be our M3? So you say 2,572, like this. 92, like this. 0.76. Okay. So now that we've obtained the moments due to each force, we can now get the resultant moment. So the resultant moment, or the sum of the moments, will be equal to, now you just have to add these. So what will be this plus this plus this? Then negative. And then conclude that. So yeah. Getting negative 11,192.72. Like this. What I'm getting? Yes. Okay, so this becomes So the question wanted to determine the resultant moment about point A. We have done that. Now they want us to determine the resultant moment about point B. So how about point B? What are we doing there? So let's do that. Now observe that in as much as we not say that A has a fixed support, and having done reaction supports, a fixed support to have reactions there. The question is specific that what the resultant is due to the forces one to do. So based on that, we will not think about the moment caused, the moment caused by the or the reaction forces. We will restrict ourselves to just the combination of the moments due to F1, F2, and F3. We know at end there will be a couple moments being a fixed support. But again, the combination of the moments due to F1, F2, and F3. These are the five somewhere right on top here. This is where B is. Then right at the bottom, we have F3. We express F3 in components. So we only have 160, sin 30, and then the component 160 for special. Next, but F1, let's go to F2 already represented in component as a component that goes like this. Component that goes like this. The vertical component, we dealt with it, that was 400 vertical component. The horizontal component, we usually handle it since we didn't go that far, we're not interested in it. But we know that sine theta will be equal to 3 or 5. So the horizontal component F2 will be 500 multiplying sine theta, which is 3 or 5. And this will give us 300. So the horizontal component is 300. Next, we have F1. F1 is vertical, 375. The distances remain the same from here to there. This was 6 feet. From here to there, we have 5 feet. Okay. So with this done, let's get the moment. Notice that I have not included the support reaction inside. So when you sum the moments, the forces, and I'm going to the three forces, you can get the moment M1 due to F1. So about point B now, M1 is now causing anti-clockwise, because the anti-clockwise rotation. So we know it will have to be positive. The distance now will be 6 plus 5, which is going to be there. What will be the answer here? Like this. F2 has two pieces. Observe that the x component of F2 again comes to pass through B. So it created about B. Only the vertical component again will create about B. You see that this time around it will be an anti-clockwise movement about B, so it will be positive. The distance. Next, go to F3 relation moment. F3 now, you see that the line of action, the vertical force, comes pass through B. Based on this, the vertical component of F3 will not create a moment about B. One horizontal component. Okay? So that this will also represent the anti-clockwise moment. So it will be the distance there. Look at the distance will just be this structure. And that was 0.5. Is this going to be 40? So now that we are done getting everything there, we can get the resultant. The result moment due to the three forces will be equal to the sum. So the sum there we have 6,000, then plus that 40. Verify this.
Yes, accepted.
Okay, so that concludes this question. Any questions here?